Question 1, solve this. So we need to find d. First thing let's do is multiply across. So I'm going to do 2 times this, 8d minus 3, equals 5 times this, 3d minus 7. Multiply out the brackets. 16d minus 6 equals 15d minus 35. D's to the left, so we'll subtract this 15d over here. So 16d minus 15d. And we will add the 6 over here. So minus 35 plus 6 gives me d. 16 minus 15 is 1. So 1d equals minus 35 plus 6 is minus 29. D is negative 29. Okay, question 2. A. First 4 terms of the linear sequence are this. Write out an expression for the nth term. Okay, there's the quick way to do this, guys. Let's just get the d. It's 3.5, 3.5. And then there's a way with the formula. I'm just going to use the formula. The formula is un equals a plus n minus 1 d. This is the formula for the nth term. So the nth term, u of n, is equal to the first term, 15, plus n minus 1 times 3.5, which is 15 plus 3.5n, that's 3.5 times n, minus 3.5, because 3.5 times minus 1, and this gives me 3.5n plus 15 minus 3.5 is 11.5. To b. A different linear sequence has nth term. This, work out the value of the first negative term in the sequence. Okay, the first negative term. Let's find out. Consider 318 minus 9n equals 0. Let's find out when this equals 0, and the first term will be the term after whatever the answer to this is. So let's solve this. I'll get 9n equals 318, and then n is equal to, if I do 318 divided by 318 divided by 9, which is 106.3. Let's just write this as a decimal. 35.3333, 35.3 recurring. Therefore, the first negative term is the first negative term is the 34th term. So therefore, no, sorry, what am I saying? The 36th term. So therefore, this 36th term, and he says the value of the first negative term. Okay, so I need to sub 36 in here. So it's 318 minus 9 times 36. 318 minus 9 times 36 is negative 6. So the answer is negative 6. Question 3. Work out the value of t and u. Okay, so we're going to multiply out the matrices. We do row times column. So 3 times 1 is 3, plus 5 times 4 is 20. That's the top. Well, this is only going to be a 2 by 1 matrix. So then we do this times this. So u times 1 is u, and 2 times 4 is 8. So it's u plus 8, and this must equal t 6. So it's just 3 plus 20 equals t, which is obviously 23. And u plus 8 equals 6. So u is negative 2. Okay. Question 4. A line passes through P and Q. The midpoint in P and Q has x coordinate 5. The gradient of the line is 2. Work out the value of k. Okay, 4 marks, guys. We're going to use the midpoint formula and the gradient formula. So, midpoint formula, that is 1 plus, or so it's x1 plus x2 over 2, comma y 1 plus y2 over 2 equals 5 something. Now, we only needed this one, guys, so we didn't have to do that. But this here must equal this. So 1 plus r over 2 equals 5. 1 plus r over 2 equals 5. 1 plus r equals 10, cross multiply, and r is equal to 9. Okay, so now we have r is 9. Next bit of information they give us is the gradient. So gradient m is equal to y2 minus y1, that is 6 minus k, over x2 minus x1, 9 minus 1. And this is equal to 2 because he says the gradient is 2. Okay, so 6 minus k over 8 equals 2. 6 minus k equals 8 times 2, which is 16, minus k is equal to 10, which means k is equal to negative 10. And that's what he was asking for. What's the value of k? So negative 10. Question 5. Work out the value of x for which the rate of change of y with respect to x is this. Okay, rate of change, guys, is dy dx. So we'll get the derivative. Dy dx is equal to multiply by the power. 4 times 0.5 is 2. And subtract 1 from the power, which is 3. So this must equal 6.75. So 2x cubed equals 6.75, because he says the rate of change, the derivative, is 6.75 equals 6.75. So x cubed is 6.75 divided by 2, which I believe, guys, is 3. I need a calculator. 6.75 divided by 2 is 27 over 8. Okay, I actually prefer that, guys. This is 27 over 8. The reason I prefer that is because when I cube root that, the cube root of 27 is 3, and the cube root of 8 is 2. Obviously, you can do it on the calculator. Okay, question 6. The equation of the circle is this. Complete these statements. The coordinates of the center of the circle are, okay, guys, we should just definitely know this. The coordinates of the center, so it's -7 and 4. It's kind of like the opposite signs of what you see here. And the radius is the square root of 36, which is 6. There we go. That's it. Question 7. Here's a sketch. The curve intersects at -4 and p. Fine. The turning point has x coordinate 0.5. Work out the value of p. Okay, well, this distance here, guys, is 4.5 to get to here. So this must be the same because the vertex is going to be exactly in the middle. So that's plus 4.5. So what's 0.5 plus 4.5? It's 5. So p is equal to 5. Okay, then he says, solve ax squared plus bx plus c is greater than 0. Okay, well, it's greater than 0. You just have to look at the graph. They've actually done, this is a quadratic inequality, guys, and they've done what I consider the hard work for you, which is actually graphing it. So they've graphed it. Where is this bigger than 0? Well, here and here. So any values bigger than p and less than -4. And we know, guys, p is 5. So the answer is x is less than -4, comma, x is greater than 5. That's it. Question 8. ABC is a triangle with perpendicular height AD. Fine, it's 4. The area of ABC is 25. BD to DC is 2 to 3. Work out the size of angle W. Okay, so we're given the area, we're given the height. Let's work out BC first. So base times height. So BC, let's call this BC. times 4, and base times height divided by 2 equals 25. So that means if you just divide here, guys, that goes in once and twice. BC is equal to 25 over 2. Okay, and then it is in the ratio of 2 to 3. So now I need to do 2 plus 3 is 5, because I'm going to split this. I'm going to split this length in the ratio 2 to 3. So I break it into 5 parts. 2 plus 3 is 5. Then I do 25 over 2 divided by 5. If you divide this by 5, you just divide the top by 5, guys. It's 5 over 2. You can actually use your calculator if you want. And then this is in the ratio of 2 to 3. So this is equal to 2 of these, so 10 over 2, or 5. And this is equal to 3 of these, so 15 over 2. So this DC is 15 over 2, or let's go with 7.5, seeing as we're going to get W. Okay, now I can get W using tan. The tan of W is equal to opposite over adjacent, 4 over 7.5. Therefore, W is equal to the inverse tan of 4 over 7.5. Let's do that. It's the inverse tan of 4 over 7.5, which is 28.07. He doesn't tell you what to round to, guys, so 2 decimal places is fine. He actually accepts quite a large range of values. Okay, that's question 8. Question 9. Dimensions of the cuboid are given. The total length of all 12 edges is 300. Show that y is equal to this. Okay, so the total length. So we've, how many, let's think, how many 3x's? So there's 1, 2, 3, 4. There's 4 3x's. 4 times 3x. Plus, how many 2x's? Well, it's actually going to be the same. 1, 2, 3, 4. There's 4 2x's. And there's 4 of these. 4 times x plus 2y. And that must all equal 300. Okay, now we're trying to show this. So fine, let's multiply this out. This is 12x plus 8x plus 4x plus 8y equals 300. Add the x's. This is 24x plus 8y equals 300. Okay, divide everything. I think, guys, we can divide by probably 4. 300 divided by 4 is 75. Okay, divide everything by 4. We get 6x plus 2y equals 75. These numbers are looking good. 2y equals 75 minus 6x. Subtract this 6x. And then y is equal to 75 minus 6x all over 2. Okay, that is question 9. B. The volume of the cuboid is V. Show that V is equal to this. Okay, volume, guys. Let me just write it up here. The volume equals 3x times 2x times x plus 2y. This is base, or length times width times height. So this is the volume of the cuboid. But we know y is this. So let me just write volume is equal to, this is 6x squared. Let's just write that, these two together, 6x squared. And then I have x plus 2 of these. Now 2 of these, guys, the 2 is going to cancel. So it's going to be just well, let's write it. It's 2y, so 2 of these 75 minus 6x over 2. These cancel. So we're left with, at this point, guys, I'm going to bring this down so we can see what's happening down here. Okay, and then this is equal to 6x squared into x plus 75 minus 6x. This is equal to 6x squared into 75 minus 5x, because x minus 6x is minus 5x. This is equal to 6 times 75, I'm guessing it's 450. It is, so that's 450x squared. And then this times this is minus 30x cubed, which is what we wanted, QED. Part C. He then says, use calculus to work out the maximum value of v as x varies. Okay, so we have v is equal to 450x squared minus 30x cubed. Okay, when he says use calculus, obviously we're going to have to get the derivative. The maximum is when dv dx, the derivative, equals 0. So let's get, when you see maximum, guys, think derivative equals 0. So then we're going to get the derivative, dv dx is equal to, multiply by the power, 900x, subtract 1 from the power, multiply by this power is 90x, and then squared, subtract 1 from the power. This, so I'm going to say at max, at a maximum, dv dx equals 0. So 900x minus 90x squared equals 0. At this point, we can divide by 90 because it's equal to 0. So divide everything by 90. This will become 10x minus x squared equals 0. Factorize out the x. 10 minus x equals 0. So we have x equals 0 or x equals 10. Now definitely, guys, the maximum volume is not going to happen when x is 0, because look, if x is 0, we don't actually even have a box because it doesn't have any length. So it has to be when x is 10. So let me just draw a line here. Max when x equals 10. So we're going to sub in 10 here. So I'm going to get v is equal to 450 times 10 squared minus 30 times 10 cubed. This is 450 hundred, and this is 30,000. Obviously, guys, you can use your calculator. 45,000 minus 30,000 is 15,000. This is 15,000. Okay, that is 9. Question 10. Line K is greater than this. L passes through this point. Tick the correct statement. Are the lines parallel, perpendicular, or neither? Show working to support your answer. Okay, so basically this question is about gradients, guys. So let's do K first. K, it has this equation. Let's rearrange it. So I have minus 5y equals minus 4x plus 17. So I'm just trying to write this in the form y equals mx plus c. So I just subtracted the 4x to the right. Now I'll divide by negative 5. So it's minus 4x over minus 5 plus 17 over minus 5, which gives me y equals 4 over 5x, because minus minus positive, minus 17 over 5. So his gradient, this guy's gradient, is 4 over 5. This guy's gradient L, let's do them over here. L, M is equal to y2 minus y1, 16 minus 6, over x2 minus x1 minus 5 minus 3. This is equal to 10 over negative 8, or negative 5 over 4 simplified. Now look, this is 4 over 5. This guy is minus 5 over 4. Negative reciprocal of each other, so that means they're perpendicular. So we take this one. Okay. Question 11. Expand and simplify. Okay, fine. Let's do this. 2x cubed minus 9 times 3x squared plus 4. So we're going to do this times this, this times this, this times this, this times this. And we get 6x to the power of 5. That's this times this, plus 8x cubed. This times this, minus 27x squared. And this times this, minus 36. Okay, then let's do this one separately, guys. This is x times x minus 4 squared. That's equal to x times this one expanded, guys, is x squared minus 8x plus 16. Make sure you do that correctly. And then this becomes x cubed minus 8x squared plus 16x. That's just multiplying all these by x. Okay, now we need to add this and this. So this becomes, okay, I guess I have to write them all out. 6x to the 5 plus 8x cubed minus 27x squared minus 36 plus x cubed minus 8x squared plus 16x equals, there's only one term with x to the 5, that's my 6x to the 5. I have an 8x cubed plus 1x cubed, that gives me plus 9x cubed. I have a minus 27x squared minus 8x squared is minus 35x squared. I have a plus 16x on its own and a minus 36 on its own. And that's it. That is it expanded and simplified. Question 12. Okay, pyramid. This is 15. This is the center. This is 28. Work out the size of the angle that VA makes with ABCD. Okay, so just so we're clear, guys. VA, draw a line from V to A. That's this line here. And then we have to go back directly underneath the V to find the triangle that will essentially give us the angle. So this is a right angle triangle, everybody. It's in 3 dimensions. It doesn't look like a right angle triangle, but I assure you it is. Okay, so that's a right angle. This length we know is 28. We're trying to find the angle that VA makes with the plane. So we're actually trying to find this angle here. Let's call it theta. So to find this angle, we need 2 lengths in this red triangle. We have one, 28. We just need another one. We don't have the height, but we can probably figure out this length here. Let's call it y. So this is 15. Why don't we draw another line all the way to here? This is 15 there. And by getting this big blue line, we can just half it to give me AX. So let's call this big blue line y. So Pythagoras' theorem, y squared equals 15 squared plus 15 squared. This is 225 plus 225 is 450. So y squared is 450. Y is equal to the square root of 450. Root 450, everybody, is root 450 is 15 root 2. Okay, 15 root 2. Therefore, AX equals half of this. So it's 15 root 2 over 2. Or why don't we just put it as 7.5 root 2. Okay, that means this length, let's just make it a pink length here. This length is 7.5 root 2. Now I can use my triangle, SOHCAHTOA. I can say the cosine of theta is adjacent, that's my 7.5 root 2, over hypotenuse, which is 28. Theta is therefore the inverse cos of that. So it's the inverse cos of 7.5 root 2 over 28, which is 67.74. 67.74. Again, guys, 67.74. They give quite a large range of values that are acceptable. 67.74 is definitely one of them. Okay, question 13. Circle the expression equivalent to this. Okay, I would argue, guys, at this stage in further maths, you should know what this is. X to the minus 7 is 1 over x to the 7, so 3x to the minus 7 is this. Okay, part B. Simplify fully this thing. So this is 12w to the 8 over 4 squared is 16, so we need to put 16 here. And w cubed squared is w to the power of 6. Then we do 12 over 16 is 3 over 4. And w to the 8 over w to the 6, we subtract them. That's just w squared. It's therefore 3w squared over 4, or 3/4 w squared is the same thing. Okay, that's 13b. All right, we have 13c. Work out the least possible values of c and d. Okay, this, guys, is finally an interesting question. Sorry, I say finally, but the first few I think have not been that interesting. Okay, so let's have a look. This, guys, let's turn all this into powers. So this is y to the power of a half times y to the 1 over 3. And this is equal to y to the power. Now I just add these two. A half plus a third is equal to, that's 3/6 plus 2/6, which is 5/6. So this is equal to y to the power of 5/6. Now, if you remember, guys, flower power, which is something I use to deal with these fractional indices, if you have 5 over 6, 6, the one that's underneath the ground, if you like, is the root, and the one above the ground is the power, hence flower power. So c is the root, which is 6, and d is the power, which is 5. Well, the reason I said this is interesting, guys, because he says the least possible values, but the reason he says that is because if y, for example, was a bigger number, like a non-prime, for example, you could technically work it out so that c and d were different values. But anyway, there you go. That's the answer. Question 14. Simplify this fully. Right, I'm going to first, guys, factorize this. This is brackets a. I need factors of negative 16 that add to give me 6. It's definitely going to be 8 and negative 2. So it's a plus 8 and a plus 8 and a minus 2. Just double check that, guys. That's a squared minus 2a plus 8a minus 16. That is correct. Okay, and this is times 8 minus 4a. Now, what I'll do with this guy, everybody, if you're okay with this, is I'm going to factorize out the 4. And this will give me 2 minus a. Okay, and this is all over 3a. Okay, the 3 into 3 goes once, 3 into 15 goes 5 times. A into A goes once, and A into A squared goes A times. So I have 5A at the top here. Okay, next one. The 2 minus A, guys, and the A minus 2. You can, okay, let me do this in 2 steps. I'll write this as 5A. This is A plus 8. This is A minus 2. And then this is times 4. Well, what I'm going to do is I'm going to take out the negative. So let me tell me if you're okay with this. This is minus 4. I'm taking out negative 1. And this becomes minus 2 plus A. Because look, if you multiply this out, you're still going to get 8 minus 4A, which is this. I could have taken it out at the beginning if I'd seen what was going to happen, but it doesn't matter. Okay, but now these cancel. This is a good thing. Minus 2 plus A and A minus 2 are the same thing, so they cancel. And we're left with 5A times negative 4 is negative 20A over A plus 8. So this is minus 20A over A plus 8. Okay, that is 14. 15. The function g is given by this. It's an exponential function. The domain of the function is this. P is this, Q is this. Work out the range. Okay, the range, guys, is going to be the y coordinate there to the y coordinate there, because the range is the y values. This will be the smallest y value, and this will be the largest y value, because it's just an increasing exponential function. Okay, so first we need to find what the function is. We need to find a and b. So we'll find a and b using these points, and I can sub in, this is x and this is y, this is x and this is y. So I can sub in these points into here. So let's start with p. I'll sub in y for g of x, so a half equals a times b to the power of x, b to the power of 0. B to the power of 0 is 1, so we're left with a is equal to a half. Okay, nice. So we've got a is equal to a half. Then let's sub in this coordinate. Y is 3 over 2. So 3 over 2 equals a times, I now know a, it's a half, times b to the power of 1. B to the power of x, x is 1, so it's just b. And then multiply both sides by 2, and I get b is equal to 3. Okay, good. Now I have g of x, guys. It is a half times 3 to the power of x. I can then get g of negative 1, which is a half times 3 to the negative 1. That's actually a half times a third. 3 to the negative 1, guys, is a third. Half times a third is a sixth. You can do that on your calculator if you need to. And then finally, we'll sub in 2 to get this one. So g of 2 is equal to a half times 3 squared. 3 squared is 9. 9 times a half is 9 over 2. So the range of the function, g of x, is therefore greater or equal to, because it's here, it is greater or equal to a sixth and less than or equal to 9 over 2. That's question 15. Question 16. 2x minus 3 is a factor of this. Solve this equals 0, give all solutions as exact values. Okay, first and foremost, everybody, I have to do this long division thing. So I'm going to do 2x minus 3 into, okay, nice, into 6x cubed minus 25x squared plus 28x minus 6. Okay, I then do 2x into 6x cubed goes 3x squared. 3x squared times 2x is 6x cubed. And then 3x squared times minus 3 is minus 9x squared. I then put a line underneath it, and I subtract. This minus this is 0. This minus negative 9 will be plus, so that will give me plus, or minus 25 plus 9 is minus 16. So it's minus 16x squared. Bring this down, plus 28x minus 6. 2x into this goes minus 8x x, multiply, minus 16x squared plus 24x, again, subtract. This is 0. This minus this is 4x. Bring down the 6, minus 6. 2x into this goes plus 2. 2 times this is 4x, and 2 times this is minus 6. These cancel, and I get 0, which I expected because it's a factor. So now this thing is this times this. So we have to solve 2x minus 3 times 3x squared minus 8x plus 2 equals 0. First thing I'm going to do is factorize this guy here. 2x minus 3 brackets. Okay, I'll do it just at the side up here, guys. I'll do my a times c is 6. Factors of 6 to give me 8 are factors of 6 to give that add to give me 8 are I don't have any factors, guys, but that means, I just realized, that means it does not factorize. Okay, so let's just leave it like that. We're going to have to solve this using the quadratic formula. Okay, so that means 2x minus 3 equals 0. Solve this, x is equal to plus 3 divided by 2, 3 over 2. So that's one of the solutions. The other solution is where this equals 0. So this is 3x squared minus, so this is r minus 8x plus 2 equals 0. Okay, I'm going to solve this with the quadratic formula. Again, very little space given. So I have x equals minus b, which is 8, plus or minus the square root of b squared minus 4ac, so minus 4, well, let's do it, 4ac all over 2a, which is all over 6. Okay, so I have 3 over 2, and then I have comma, right? Let's do the rest of this down here, guys. This is going to be 8 plus or minus the square root of 64 minus, okay, this is 24, so it's root 40. So it's 8 plus or minus root, let me just do that again, guys. 4 times 6 is 24. Yeah, that's right. This over 6, which equals 8 plus or minus, this is root 4 times root 10, which is 2 root 10 over 8 plus or minus 2 root 10 over 6, which is 4 plus or minus root 10 over 3. So my roots are 3 over 2, 4 plus root 10 over 3, and 4 minus root 10 over 3. And those are my exact solutions. Okay, question 17. The function h is given by this. A is a positive constant, h is an increasing function. Work out the possible values of a, giving your answer as an inequality. Okay, an increasing function, guys. This means, so an increasing function means if you were to graph it, it's always going up like this, right? Now, I don't know exactly what this one looks like, but increasing, it never turns, it never goes back down. The rate of increase can change, but that doesn't happen. So it's always going up. And what that means is the key point here, this is a 4-mark question, guys, and you pretty much have to get this to get any marks. You have to understand that if it's increasing, the derivative, h dash of x, has to be greater than 0. So write that down straight away. Because if it's increasing, if it's going up, the derivative will always be positive. So derivative, which is the gradient, is always greater than 0. Okay, so let's get the derivative. First, I'm going to just multiply this out, guys. So this times this gives me 3ax cubed minus 2ax plus 5x. Okay, the derivative, h dash of x, is therefore 3 times 3 is 9, ax, subtract 1 from the power squared, minus 2a, this x disappears, and 5, this x disappears. Okay, so 9a x squared minus 2a plus 5 has to be greater than 0. Okay, now this value here, guys, this 9ax squared, 9ax squared has to be, because a is positive, and x squared is positive, this thing will always be greater or equal to 0. So the minimum this can be is 0. So, but it could be 0. So if this is 0, then I need this minus 2. So I'm going to write, so minus 2a plus 5 must be bigger than 0 in order for the whole thing to be bigger than 0. Now that's kind of complicated to get your head around, but that's what's happening. Then I'll say, okay, so, add the 2a over here. So 2a has to be less than 5, which means a, let's just leave it here, a is less than 5 over 2. So the possible values of a must be less than 5 over 2, and a is positive, so it has to be bigger than 0 as well. So there we go, that's the answer. Question 18. Here's a sketch of y equals cos x. Alpha is an obtuse angle measured in degrees. The cos of alpha is negative k. Tick two boxes that show expressions for x where cos of x is equal to negative k. Okay, so he basically wants, okay, there's 6 options. He wants us to circle the ones where cos of x equals negative k, where x is this. So does the cos of this equal negative k? Yes or no? Does the cos of this equal negative k? Does the cos of this equal negative k? That's what he's asking. So let's have a look. Negative k is here. So I'm going to draw a line along, guys. Let's just draw a line straight across from here. This is negative k. Okay, so it equals negative k here at alpha. Here, whatever that's going to be. And then if I actually continue this graph down here, it'll equal k down here somewhere, or negative k there. Okay, now this is alpha. This distance from here to here, this distance is alpha. Now this distance, because it's all kind of symmetrical, this distance, let me just do this, from here to here, this distance is the same as this. So this here is actually 360 minus alpha. So that's, this one is good. And then this guy is going to be over here. Let me just draw a line at 360 so we know what's going on. This distance here is also, this distance here is also alpha. So look, that distance is alpha, that distance is alpha, and that distance is alpha. So this is 360 plus alpha. Okay, so that's kind of confusing, guys. So 360 minus alpha and 360 plus alpha. Okay, then he says, circle the expression for x where sine of x is equal to minus k. Okay, now if this is cos of x, what is sine of x? Okay, now sine of x, watch this, guys. Sine x is, I need a new color. Okay, let's go pink. Okay, this is cos x. Now bear with me, guys. I'm just gonna copy this cos x curve like this, and then I'm going to move it because sine x is actually this. Sine x is very like cos x, except it's 90 degrees translated to the right. So this is y equals sine x. Okay, now where does this equal minus k? Well, it equals minus k certainly down here, but what's that value? Well, look, everything's been moved to the right by 90 degrees. So if this guy's at alpha, we're going to move it to the right. This is being moved to the right by how much? Well, it's by 90. So what is this value here? Well, it's actually alpha, this alpha, plus 90. So this is alpha plus 90. So the sine, where does sine of x equal negative k? Well, it's sine of 90 plus alpha equals negative k, because sine x is essentially cosine x being translated to the right by 90 degrees. Okay, that's quite a confusing question, guys. I hope it makes sense, but that's question 18. Question 19. In these simultaneous equations, k is a positive constant. Solve the simultaneous equations. Give your answer in this form. Okay, so we answers are going to be in terms of k. Okay, so I'm going to sub this into here. So 3x plus 4, instead of y, I'm going to put 2kx equals k. Okay, then I have 3x, multiply out the brackets, 3x plus 8kx equals k. I want x on its own, so I'll take out the x, and I have 3 plus 8k equals k. X equals k over 3 plus 8k. Fine. Once I have x, I can get y, because y is equal to 2kx. So y is equal to 2k times k over 3 plus 8k, which equals 2k squared over 3 plus 8k. And that's it. That question, guys, actually wasn't that bad at all. So it's k over 3 plus 8k and 2k squared over 3 plus 8k. Okay, question 20. Show that this simplifies to p sine x, where p is a positive constant. Okay, definitely, guys, there's going to be a Pythagorean identity in here, and there's going to be sine over cos in here. Let's have a look. Okay, so I think let's take out a sine here, right? So if I take out a sine x, I'll take out a 2 sine x from the first 2. So this is 2 sine x into sine squared x plus cos squared x, which is immediately what I wanted, because that's going to be 1. That's the Pythagorean identity. Plus 5 tan x, guys, is sine over cos. So it's 5 sine x over cos x, that's tan x, times cos x. Now, these two cancel. So I'm left with 2, this is actually also, guys, very easy, 2 sine x times 1 plus 5 sine x, which equals 7 sine x. And that's it. Question 20. Question 21. A, B, C, D, and E are points on a circle. Work at the value of x. Okay, thankfully, guys, we don't have to do or give the reasons. Okay, it's not a quadrilateral, guys, so I can't do opposite angles in a cyclic quadrilateral. What I can do, though, is I know at least that these two are the same because they're both radii, radiuses. So this is an isosceles triangle, which means this is 2x, and then this is 180 minus, sorry, this is 180 minus 4x because they add up to 180 because it's a triangle. Okay, another thing I can see, guys, is that do you remember this? Angles at the center are double angles at the circumference. So if this is 7x, then the angle at the center is 14x, but it's not this one. That's not the angle at the center. The angle at the center is this one. Now, how am I going to draw this? Let me just go straight through that. It's this angle. This angle is going to be 14x. Okay, and if this angle is 14x, this angle here, luckily I have all these colors, or let's just do it like this. This angle, let's call it y. Let's say that's y. Okay, that y plus 180 minus 4x, y plus 180 minus 4x must equal 14x. Okay, so that means y plus 180 equals 18x. Okay, so I've got an equation with y and x. I need another equation with y and x. Now I'll do the same thing over here. I'm running out of colors, guys, but this one here must equal 12x for the same reason. That's the angle at the center. That's the angle at the circumference. This must be double this. Okay, now without calling this y, I'm just going to say this plus this. Okay, let's call this, guys, z. This is the small one. Sorry, let me just be clear. This is z. Okay, so z plus, why not stick with this color? Z plus 180 minus 4x. Z plus 180 minus 4x equals, this must equal 12x. So here I have z plus 180 equals 16x. Okay, now I've got two equations, but now I have another unknown. But I can make a third equation. I'm really not entirely sure this is the easiest way to do this question, guys, but if it isn't, I will make a different video, but let's assume it is. I can make a third equation that all these, the red, purple, and blue now need to add up to 360. So 180 minus 4x plus z plus y must equal 360. Now, actually, I think this is okay because I can then, I know y in terms of x is 18x minus 180. I know z, it's 16x minus 180. So why don't I just sub that in here? So I'll have 180 minus 4x plus z, which is plus 16x minus 180, plus y, which is plus 18x minus 180, and this equals 360. Okay, 180 minus 180 cancels. Okay, 16 plus 18 is 34. 34 minus 4 is 30. So it's 30x equals 360 plus 180 is 540. And then x is 540 divided by 3, which is, hang on, that can't be right. 540 divided by 30 is, 18, which can be right, and that is right. X is equal to 18. Okay, so not an easy question, guys, but there you go. Again, Hope it makes sense. Let me know if not. That's 21. Question 22, the last question. 5-digit integers are made using 1, 2, 7, 8, 9. For each integer, all digits are used exactly once. The integers are greater than 400,000 and odd. How many different integers can be made? You must show your working. Okay, so bigger than, so I'm gonna have 1, 2, 3, 4, 5. I'm gonna have it 1, 2, 3, 4, 5. How many digits can go in here? Well, it has to be the 7, the 8, or the 9. So in there, I can only put 3. Okay. Now, the problem is, depending on which one I put in, 7, 8, or 9, the last digit has to be odd. So I'm going to have to consider the 7, the 8, and the 9 in the first one separately. So consider putting a 7 in there. Okay. So if I put a 7 into this first box, let's say, then this one has to have, so now this, the 7 is there. This guy can have, I can put a 1 there or a 9 there. So 2 can go in there. Now, I don't mean this, so just to be clear, guys, this is the digit and this is how many digits can go there. So I can put 2 digits in here, either the 1 or the 9. Now, if the 7 is here and the 1 or the 9 is here, there are only 3 left to go here. So I can put 3 times 2 times 1 times 2. And this equals 3 times 2 times 1 is 6 times 2 is 12. Okay, now consider we put the 8 there. So now if we put the 8 there, we can now put the 1, 7, or 9 here. So there's 3 that can go there. And then again, it's 3 times 2 times 1 times 3, which is 6 times 3, which is 18. And then, last one, if I put the 9 there, again, I now have, this will be the same as the 7 one. Basically, I can put 2 there, and 3 times 2 times 1 times 2, because I can either put the 1 or the 7 here. So 3 times 2 times 1 times 2 is 12. So it's this or this or this. Add them all up. 12 plus, well, let's just do it here. 12 plus 18 plus 12 is 42. And there we go. Okay, that's it, guys. That is the paper. That is paper 2. Next one I'll do is 24.